Generally, there are two types of techniques that are used to solve the peptide sequencing problem, and these techniques are used in the past by various scientists. One is the use of the algorithm exhaustive search, and the second is the use of the spectrum graphs. So in the first technique, in which the scientists use the exhaustive search algorithm, they search the different sizes of the peptides that were generated by the mass spectrophotometry, and they find the exact size of the peptides that they want to see the size of that peptide. So in this case, different sizes of peptides are generated, and we know it depends on the number of amino acids, that is 20, and also depend on the size of the length of the peptide, that is L. So in this case, a large number of peptides are generated, and this exhaustive search technique is used among all of these peptides. The second approach is to search the peptides by using the prefix, and we know that when the size of the peptide increases, the number of the different combinations of the peptide, it also increases and generates a large number of peptides of different sizes. So to overcome this problem, a technique known as the prefix pruning is used. In this technique, the prefix means that the starting amino acids of the peptides, they are considered, and the sequence is used to find the peptide of the theoretical and the practical peptides. So the problem with the prefix pruning is that if any of the peptide that is correct and matches with the experimental and theoretical peptides can be discarded by this technique if its first few of the amino acids did not match. Rather, the other sequence, they match, but if the first few amino acids does not match, it discards the specific peptide. So in the second technique, that is known as the spectrum graph approach, in this approach, the different types of peptides, they are not generated, but rather a graph is plotted and generated by using the data of the experimental spectrum. The experimental spectrum S, and we know that it's starting from S1 to SQ, consists of N terminal ions, and we know that there are different types of ions, water and ammonia and something like this, and we will ignore the C terminal ions for a while, and every mass in which S is a subset of spectrum may have been created from a partial peptide by one of the K different ions. Since we do not know which ion type, that is delta 1 to delta K, created the mass S in the experimental spectrum, and we generate K different guesses for each of the masses in the experimental spectrum. So every guess corresponds to the hypothesis that S is equal to X minus delta J, and that is delta J is the ions that is created, and where X is the mass of the small partial peptide and 1 is less than equal to J and J is less than equal to K, and every mass S in the experimental spectrum, there is K guesses for the spectrum S of many partial peptides, and we know that the partial peptides are S plus delta 1 means the one ion, and the S plus delta 2 means the second ion, and S plus delta K means the third types of the ions. And as we know that when the spectrum is created and the mass is assigned to the peptide, that mass is converted into the K vertices. And as we know that more are the vertices, better will be the path. And we assume that each vertex has a partial delta ions that is assigned to the N terminal. And if we assign the mass to any of the ions that are generated, we can write it as the S plus delta I. And we also know that we can join any of the 2 points that are present in the spectrum, and we call them as the U and V. And we join these points as a directed points, and we write it UV in the brackets. And we know that more the K vertices, better will be the path. So if we add a vertex 0 and a vertex at the parent mass M, connecting them to other vertices as before, then the peptide sequencing problem can be cast as finding a path from 0 to M in the resulting DAG. And we have already seen previously that we can plot a path in a directed acyclic, and we can find the longest path, and the longest path will be the best path in this case.